In this video, you will learn how to solve different stoichiometric problems, such as converting grams to atoms and vice versa, atoms to grams. Let's solve this problem here. How many total atoms are in a 4.98 gram sample of octane C8H18? Given the molar mass of C8H18, which is equal to 114.23 grams per mole. So in this case, we're given the mass of the sample. Our sample is octane, which has a chemical formula of C8H18, and then we convert that to atoms. So we will be converting grams of octane to atoms of octane. Now, how do we solve this? We are asked here for the total atoms of the sample octane, which is C8H18, given its mass, which is equal to 4.98 grams. So we start with the given value. So we start with 4.98 grams of octane, and then we multiply this by the molar mass of octane, which is 1 mole of octane is equivalent to 114.23 grams of octane. So we just flipped it. Instead of grams per mole, we multiply it by mole per gram instead. So we can cancel out the unit gram. This one. And now we're left with the unit mole of octane. So we just have to multiply this by the Avogadro's number in atoms. So this is times 6.022 times 10 to the 23rd atoms of C8H18 over per 1 mole of C8H18. So the number of moles here, the mole unit cancels out. Then we're left with number of atoms. But we have, for 1 mole of C8H18, it has a total of 26 atoms. 8 for carbon and 18 for hydrogen. So we just multiply this by 26. In calculating everything, this would give us an answer that is equal to 6.83 times 10 to the 23rd atoms of C8H18. Alright, let's solve another problem. A sample of octane C8H18 has 4.73 times 10 to the 28 hydrogen atoms. What is the mass of the sample in grams? Given the molar mass of C8H18, which is equal to 114.23 grams per mole. So a while ago, or previously, we converted grams to atoms. But in this case, we're given here the number of atoms of hydrogen, and then we need to convert this into mass or we need to solve for the mass of octane. So atoms, 2 grams. Alright, now to solve this, we start with the given values. So we're given here the number of atoms of hydrogen and the molar mass of octane. So we start with the number of atoms of hydrogen, which is 4.73 times 10 to the 23rd atoms of hydrogen. And then we multiply this by Avogadro's number per mole of hydrogen to convert this to number of moles. So 1 mole of hydrogen per 6.022 times 10 to the 23rd atoms of hydrogen. So we can cancel out the atom unit. And then we multiply this by the molar ratio of octane and hydrogen, because we are asked for the mass of octane, but we're given the number of atoms of hydrogen. So we need to convert this into octane. So molar ratio, that would be 1 mole of octane per 18 moles of hydrogen. So the mole hydrogen here cancels out, and then we're left with the number of moles of octane. And then we need to multiply the number of moles of octane by its molar mass, which is 114.23 grams per mole. So that is 114.23 grams octane per 1 mole of octane. Then the number of moles of octane here cancels out. Then we're left with grams, the unit grams of octane. So let's calculate this one. So that is 4.73 times 10 to the 23rd divided by 6.022 times 10 to the 23rd divided by 18 times 114.23. This gives us an answer that is equal to 4.98. No, 4,000. Be 4 point. Wow. Oh, 4.98 times 10 to the 5th. Because I got 498,457.42, and then we write this in scientific notation: 1, 2, 3, 4, 5. So that would be 4.98 times 10 to the 5th. Sorry, this should be 28 times 10 to the 28.